There is a technology that cools a house better than any air conditioner ever built. It uses no electricity. It has no moving parts. It cannot be patented, cannot be licensed, and cannot be sold to you on a monthly subscription. It is made of air, geometry, and height. It has kept humans cool through the most brutal heat on Earth for over 4,000 years. And in the span of roughly 70 years of modern construction, it was almost completely erased from architectural practice. That is not an accident. The technology is the roof, not the flat concrete slab sealing your ceiling right now, not the synthetic membrane baking in the afternoon sun. The other kind of roof, the one your great-great-great-grandparents lived under in desert cities and tropical valleys, the kind that made the interior of a home feel almost supernaturally cool even when the outside air was pressing past 40 degrees. Builders in ancient Persia, Egypt, North Africa, South Asia, and the Mediterranean all knew versions of it. The principles were not identical, but the logic was the same. And that logic, once you understand it, makes the modern construction industry look less like progress and more like a very profitable step backward. Here is the part that should bother you. The people who built those ancient structures did not have computers, climate software, or engineering degrees. They had observation and consequence. If their building did not work, they baked inside it. They had every reason to get it right. And they did. Consistently. Across continents and centuries, without coordination, without a shared language, without Google. So why are you paying an electricity bill every summer just to stay comfortable in your own home? Walk through any neighborhood built in the last 40 years and you will see the same roof repeated in 1,000 variations. Low pitch or flat, sealed tight, insulated from above, covered in dark petroleum-based material or concrete tile. The contractors who built it followed code. The architects who designed it followed convention. The material suppliers who profited from it followed the market. The problem is what happens in that sealed attic space, or in homes with no attic at all, when the summer sun hits. That roof surface absorbs solar radiation for 6 to 8 hours a day. On a clear afternoon, the surface temperature of a dark roof can reach 80 to 90 degrees Celsius. That heat pushes straight down. Insulation slows it, but does not stop it. By mid-afternoon, the ceiling below that roof is radiating heat into your living space like a slow oven element. The air conditioner kicks on. The electricity meter spins. You pay. The building did not fail. It worked exactly as designed. A home that gets hot is a home that needs cooling equipment. Cooling equipment is something the market can sell you. Twice. Once when you buy it, and again every month when you run it. Now consider the old houses. Not the romantic postcard version, but the actual structural logic of dwellings in regions far hotter than most of the places people live today. Homes in the Nile Delta in 3000 BCE. Merchant houses in Yazd, Iran, a city that sits in one of the driest regions on the planet. Courtyard homes in Tunis and Marrakech. Colonial bungalows in Colombo and Madras. High-ceilinged plantation houses in the Caribbean. Farmhouses in Sicily and southern Greece. These structures stayed cool. Visitors remarked on it. Travelers wrote home about it. Not because of magic, but because the roofs, and the spaces just beneath them, were doing something the modern sealed slab does not do. They were moving heat out before it could move in. Somewhere between then and now, that knowledge did not evolve. It disappeared. The forms simplified. The ventilation paths were closed off. The geometry was flattened. And the question nobody in the construction industry wants you to ask is, who benefited when that happened? Ancient Egypt and Mesopotamia built with high ceilings and thick upper masses. Hot air rises. This is not an opinion, it is physics. And a tall interior gives it somewhere to go. The heat stratifies upward, and the living level below stays cooler. The roof mass was thick enough to absorb daytime heat slowly, delaying its penetration until after sunset, when the desert air had already cooled. Persian architects took this further. The great domed structures of central Iran, the wind catchers called badgirs, the arched interior volumes, the narrow high openings, created deliberate airflow paths. Cool air was drawn from one side of a structure, passed across the living space, and expelled from the other. The roof geometry was not decorative. It was functional. It was an engine. Across North Africa and the Levant, builders worked with layered roof logic. A whitewashed or lime-coated outer surface to reflect the sun, a gap or lightweight structure beneath it, vented openings to release trapped heat, and a courtyard design that pulled cooler air upward through the house at night. The white color was not aesthetic preference. Lime and mineral coatings reflect a substantial fraction of solar radiation that darker surfaces absorb entirely. In South Asia and the wet tropics, the answer was steep pitch and deep overhang. A sharply angled roof sheds rain fast, but it also creates a large triangular attic volume beneath it, a buffer zone between the hot roof surface and the ceiling of the rooms below. Deep eaves shaded the walls and windows from direct sun. Clay and terracotta tiles, porous and textured, allowed minor moisture exchange that slightly cooled the surface through evaporation. The roof breathed. In the Mediterranean, light mineral surfaces and curved terracotta reflected sunlight across entire villages. In colonial architecture, buildings designed by European settlers who had learned the hard way that European construction methods killed people in tropical heat. You see high-pitched roofs, ridge vents, wide overhangs, and elevated floor plans that drew air beneath the structure. Different materials, different climates, different centuries. One principle: keep the heat from entering in the first place. Lift the roof, vent the gap, reflect the sun, let the structure breathe. Here is the physics, stripped of mysticism. Solar radiation hits a roof surface and converts to heat. If that surface is dark and sealed, close to 100% of that energy enters the building. If it is light-colored or reflective, a large fraction bounces back into the atmosphere before it ever becomes a problem. Inside a poorly ventilated attic or roof cavity, trapped air gets hot and stays hot. But hot air is less dense than cool air. It wants to rise and escape. If there is no exit, no ridge vent, no high opening, no gap at the peak, the air has nowhere to go. It sits, it presses down, it heats the ceiling below it. A ventilated roof with a high ridge vent creates a convection engine. Cool air enters at the eaves. It heats as it rises through the attic space. It exits at the peak. The movement is continuous. It requires no fan, no electricity, no thermostat. The geometry does the work. A double-layer roof, an outer shell separated from the inner ceiling by an air gap, adds insulation that no foam board can replicate because still air is one of the worst conductors of heat in existence. That gap is not dead space. It is a thermal buffer. Thermal mass, properly used, shifts the timing of heat transfer. A thick, heavy roof absorbs heat slowly during the day and releases it slowly at night when outside temperatures are low, and the penalty for that release is 0. The house does not get hot at 2 in the afternoon. It barely gets warm by midnight, and by then the cool night air has already begun the cycle again. Breathable materials, clay, lime, wood, thatch, allow small amounts of moisture to migrate outward. Evaporation requires energy. That energy comes from the surface heat. The roof cools itself. The ancient roof was not a lid. It was a cooling device. It did not wait for heat to fill the house and then fight it. It intercepted heat before it arrived, redirected it, released it, reflected it back into the sky. 4 independent mechanisms working in combination, in silence, at no operational cost. When you understand that, the modern sealed concrete slab does not look like an upgrade. It looks like a deliberate removal of something that worked. The question is, why? And the answer is not flattering to the people who built the industry that replaced it. Let's be precise about what happened. Nobody held a meeting. No executive in a boardroom stood up and said, "Gentlemen, let's make sure every house on earth overheats so we can sell the solution." That is not how industries kill good ideas. They do it slower, quieter, and with much better plausible deniability. They do it through incentives, and incentives over time are more powerful than any conspiracy. The modern construction industry does not reward solutions that make buildings self-sufficient. It rewards solutions that are fast to build, easy to standardize, and guaranteed to generate follow-on revenue. A roof that cools itself through geometry and airflow does not generate follow-on revenue. A roof that traps heat and forces the occupant to buy mechanical cooling does. Every single year, for the entire lifespan of the building. Think about what that actually means in practice. A flat or low-pitch sealed roof is cheaper to build per square meter than a high-pitched ventilated structure. It requires less skilled labor. It goes up faster. The developer saves money on construction. The buyer, who will not feel the thermal consequences until after they have signed the paperwork and moved in, pays the difference over the next 30 years in electricity bills. The developer has already moved on to the next project. This is not greed in any dramatic sense. It is simply a misalignment of who pays and who benefits. The person who builds the house does not live in it. The person who lives in it did not design it. And the industry that profits from the discomfort, the air conditioning manufacturers, the energy companies, the insulation sellers, the duct installers, the maintenance contractors, had no seat at the table when the house was designed and no reason to complain about the result. A home that overheats is a revenue stream, not for one company. For an entire ecosystem of companies, each solving one symptom of a problem that was designed into the building from the first day of construction. The numbers tell the story without any need for dramatization. The global air conditioning market is currently valued at well over $100 billion per year and is growing faster than almost any other consumer hardware category. In the United States alone, air conditioning accounts for roughly 6% of all electricity consumed annually, approximately 220 billion kilowatt-hours, at a cost to consumers of around $29 billion every year. In countries across South and Southeast Asia, where new construction is happening at enormous scale using exactly the flat slab, sealed roof model exported from Western construction norms, air conditioning adoption is accelerating at a rate that will add hundreds of millions of new units to the global grid within the next 2 decades. Every one of those units is, in part, compensating for a roof that does not do its job. The companies that manufacture those units know this. The energy companies that power those units know this. The construction industry that produces the buildings requiring those units knows this. None of them have a financial incentive to point it out. The architect who specifies a building envelope has already been paid before the first summer. The contractor who poured the concrete slab is building the next project. The equipment dealer who sells you a 4-ton split system is simply filling a demand that the building created. The system is not malicious. It is just structured so that the people who could fix the problem at the source are never the people who experience the consequences of leaving it unfixed. And here is where the story becomes something more uncomfortable than a conspiracy. A conspiracy requires intention. What happened to the cooling roof was not really intentional. It was structural. It was the slow accumulated result of thousands of individual rational decisions, each of which made sense in isolation and together produced an outcome that serves the industry and costs the homeowner. Schools of architecture stopped teaching passive cooling principles because the profession moved toward climate-controlled buildings as the universal standard. If the building has mechanical cooling, the thermal performance of the envelope becomes a secondary concern. You design for appearance and function. You let the HVAC engineer handle the climate. building codes in most of the world stopped requiring ventilated roof assemblies as climate-responsive design gave way to prescriptive insulation standards. Add enough foam, the code says, and the thermal resistance will be sufficient. What the code does not say is that resistance is not the same as rejection. Insulation slows heat entry. A properly ventilated roof prevents it. Developers stopped requesting high-pitched ventilated structures because buyers stopped expecting them. Buyers stopped expecting them because every house they had ever seen was built the same way. The reference point shifted. A sealed flat roof became normal. The idea that a roof could actively manage heat became, over a generation or two, something that sounded impractical, old-fashioned, the kind of thing people did before modern engineering solved the problem. Except modern engineering did not solve the problem. It monetized it. The industry learned, structurally and financially, that an overheated house is a dependent house. A dependent house is a customer. And a customer, unlike a well-designed building, keeps paying. Here is what you can actually do about it. Not in some hypothetical future rebuild, but in the building you are living in right now, or the one you are planning to build or renovate. The first and highest leverage intervention is ventilation at the ridge. If your roof has an attic space, that space needs an exit at the highest point and an intake at the lowest point, typically the soffits at the eave line. Hot air accumulating in the attic needs a path out. Without a ridge vent or equivalent high exhaust point, it has nowhere to go, and it presses down into your living space. Adding ridge ventilation to an existing roof is not a major structural project. It is, in many cases, a single day of work. The thermal improvement is immediate and permanent. The second intervention is separation. If you are building new or doing a significant re-roof, consider a raised or double-layer assembly, a ventilated air gap between your outer weatherproofing layer and your ceiling. This does not require exotic materials. It requires spacing and geometry. Even a small gap, 50 to 100 millimeters, dramatically reduces conductive heat transfer through the roof plane. The air in that gap is doing work that no insulation product can replicate at the same cost. The third is reflection. The color and texture of your roof surface determines how much solar radiation converts to heat before it ever reaches your structure. A dark roof on a hot climate house is an engineering error that the roofing industry has spent decades normalizing. Lime wash, light mineral coatings, terracotta, and light-colored metal roofing all reflect a substantially higher fraction of incoming solar energy than dark asphalt or concrete. In some climates, this single change reduces peak attic temperature by 15 to 20 degrees Celsius. That is not a marginal improvement. That is the difference between an air conditioner running for 8 hours and running for 3. The fourth is overhang. Deep eaves are not aesthetic. They are thermal shields. A roof that extends well past the wall line shades the upper portion of your walls and windows during the high sun hours of the day, preventing direct solar gain through the building envelope. Modern construction has progressively reduced overhang depth in the name of cost and a certain minimalist aesthetic. The thermal cost of that decision is paid by the occupant every summer afternoon. The fifth is ceiling height. Hot air rises. This is not negotiable. A high ceiling gives the warmest air in your room somewhere to go that is not directly around your body. Low ceilings, the 2.4-meter standard that became universal in residential construction sometime in the mid-20th century, are thermally indefensible in any climate that experiences heat. They exist because they are cheap to build. Every 30 centimeters of additional ceiling height costs money at construction and returns that money in comfort and reduced cooling load for the lifetime of the building. Beyond these 5, the principles compound. Cross-ventilation, windows and openings positioned to create airflow paths through the building, amplifies the effect of every other intervention. Shaded openings, deep window reveals, covered porches, and verandas. All of these reduce the solar load on the building envelope before it becomes a thermal problem inside. Breathable materials, lime plaster, clay tile, untreated timber, allow minor moisture exchange that, through evaporation, slightly reduces surface temperatures. None of this is complicated. None of it requires a special product, a proprietary system, or a certified technician. It requires geometry and the willingness to take heat management seriously at the design stage instead of outsourcing it to a machine after the fact. The smart modern house does not copy the past literally. It recovers its logic. Here is the truth the modern comfort industry does not want you to sit with for too long. You were taught that cooling starts with a machine. Ancient builders across 4 continents and 40 centuries knew that cooling starts with design. The roof was supposed to be the first line of defense, not a passive lid that traps heat and forces everything below it to suffer, but an active thermal system that intercepted the sun's energy at the point of contact and dealt with it before it became your problem. When that idea was abandoned, not dramatically, not with a press release, but quietly, gradually, through the slow accumulation of cheaper decisions and misaligned incentives. The consequence was not just higher electricity bills. It was the transfer of an entire category of architectural knowledge from the building itself into a product you have to keep purchasing. The comfort that a well-designed roof once provided for free became something you rent from the energy grid, month after month, for the entire life of the building. That is not progress. That is a substitution. And it is a substitution that benefits everyone in the supply chain except the person living inside the building. If you made it to the end of this, you now know something that most people who design, build, and sell houses either do not know or prefer not to think about too hard. You understand why the ancient roof worked, why it disappeared, and what it would take to bring its logic back, not as nostalgia, but as engineering. Share this. Not because ancient wisdom is always right, but because this particular piece of it was correct, proven, and profitable to forget. The more people who understand the logic of the cooling roof, the harder it becomes to keep selling the problem as the only available solution. The house that cools itself is possible. It always was. Someone just needed you not to know that.